So when it comes to non-trivial GUI applications, a mature framework like Qt really is much nicer than the bare bones functionality that GLFW or any of the other bare bones libraries for OpenGL provide, and still work in a cross-platform manner. So this is really nice. Before I check out the next step, let's look at the designer, Qt designer real quick right now, and look at the OpenGL widget right now. So this is the basic OpenGL widget that makes up the majority of the screen, and so we're gonna change that now in the next iteration, and actually um, um, promote that particular class to our own GL widget that derives from OpenGL, from the Q OpenGL widget, and then allows us to connect the sliders via signals and slots to the functionality of that widget. So let's do this. I'm going to check out the final version that you will also start working on. And as always, let's compile this real quick and give you a quick demo of the functionality. So now you see that we have the model in Lambert lighting, and now I can actually rotate the model around the y-axis, the z-axis, and the x-axis. At the same time, I can also move around the light around the model. So this is around. Remember that the light is 3 meters behind us, so this is in phi. So this is around the center of the model, and then I can also move the light up and down. So this is straight from the top. 0 degrees is the north pole of the sphere that makes up the light direction space, and then I can actually move the light to the bottom. One of the things that you can actually see here, because quite obviously when I light it from the bottom, I should not be able to see such a highlight on the knob of the lid, and that is quite obviously because we haven't taken shadows into account. And shadow casting is a separate topic from this. And the book, of course, talks about shadow casting, but we haven't done that here yet. But as long as we don't have very prominent shadows, the whole thing actually works relatively impressively in terms of realism. So let's see how we did this. So, the first thing we actually did in terms of the widget is we provided a couple of signals and slots that are connected to X, Y, Z rotation and theta and phi. So that's happening here. So I got a couple of slots to set it and a couple of signals to signal that they actually have changed. So that's that. Of course, we have a couple of new data members that represent these numbers. And then when we draw that, so we'll just basically see here that what we do after the translation is that we just rotate with the X, Y, and Z rotation around the corresponding axis. And the same thing here for the light. We compute the light position in spherical coordinates based out of theta and phi, which happens here. We set the corresponding position of the light with a fixed light distance, again, of 3 meters, and pass that into the shader, and then the shader just takes that information. And the shader, in this case, really doesn't change at all. So that's from the drawing point of view, but how do we connect the elements and the signals from the sliders? So, and that's actually relatively simple when we use the Qt IO designer. So let me just close this and reload it, because the designer cannot really handle automatic reloads. But what you see now here for the OpenGL widget is that I've manually, and you can do this in the creator, in the designer. So I've manually promoted that widget type to a GL widget. So you can right click on this here and then here promote or demote. So we have pre-moted it from OpenGL widget because we inherited from it to GL widget, which is our class. And then you can manually add the slots that you have actually added in the code, which happens right here. So and all I do now is, for instance, here for changing the Z rotation, is that I set up a single slot connection from the sender, in this case the Z slider, with a signal of a value change that transfers the int to the receiver object, which is our OpenGL widget, and the slot set Z rotation. And that's all I really need to do this. I pick sensible defaults, which you can see here with the slider positions that I've just entered here. For instance, here we can actually click on the slider and we see that there is a slider position set to 310 degrees right now for X. And then to actually work with the starting points specified in the designer, we can go back to our code here and go to the main window. And then we just retrieve the slider values right here. So this is the X slider value, and then set the rotation before when we set up the GUI and before we even create the rest of the windows. And that's how we get the values, the default values from the GUI designer into the code. And that's really all there is to it. We just set that up, so it's very convenient and very powerful mechanism here. And again, when I play this back, we see that I can now see the default view that I've specified and that the sliders actually work. So all that's left for it at this stage now is for you to implement Blinn-Phong, and at the beginning of this I've showed you how the Blinn-Phong rendering then actually looks, which is already fairly impressive. Let's do this one more time. So I just check out the Blinn-Phong code already with the gamma correction, and then can run this code. And the difference is relatively stark. As you can see, the surface looks a lot smoother. We get these nice specular highlights when we rotate things around, and we actually see quite nicely that this model is fairly impressive. What of course is, as I already said, missing here is casting shadows, but absence of that, the overall view is already fairly realistic.